Okay, in the previous section we talked about confidence intervals for the standard deviation, and to do that we needed the chi-squared distribution. Okay? Now that was the introduction to the chi-squared distribution. So now we're going to talk about how to actually find confidence interval for the standard deviation and variance. Now, what you normally do is go through all of the work to find the confidence interval for the variance. And then, if they're really asking you about the standard deviation, you take your answers you got here and then just square root them. Okay? So let's go ahead, let's write the relevant formulas that we need up here real quick. Remember, we're going to need the chi-squared distribution table. So here's the confidence interval. For variance. We saw this in the last section. It's n minus 1 times s squared divided by the chi-squared right value is less than sigma squared, which is less than n minus 1 s squared divided by the chi-squared left value. Now, for standard deviation, again, we're going to do all the work to find the confidence interval for the variance, and then if you just want the standard deviation, you just square root your answers. Is less than, sigma is less than n minus 1 square root s squared divided by chi squared. And then remember, when we find these critical values, you do not square them. Do not hit the squared button, type the number in, and hit the squared button on the calculator. That is not what we're doing here, okay? It's just notation. Chi-squared is the name of the distribution. Okay, so let's see. Let's read our first example. It says the weight in pound of 15 dogs selected randomly from those adopted out by an animal shelter last week are shown in the list below. So they told us the sample size, n is 15 dogs. Construct a 98% confidence level, so 0.98 is our confidence level. So if we were to find alpha, that's 0.02. Let's see. Okay, so that's all the information they give us. We don't know what our sample standard deviation is, so we have to find that, okay? So go to stat edit and enter in the data that we have here. So 25, 34, 27, 27, 31, 28, 27, 28, 33, 31, 28, 29, 32, 29, and 29. Go ahead and give it a good look through and make sure all the numbers you entered in into the calculator are correct. I do have mine correct. Actually, I just realized the table that I gave you guys was a very condensed table. Just to explain it, they have bigger tables. We don't have this on the table I currently gave you in the last section. Let's just make it a 95% confidence interval, just because I know that's on the table. That means our alpha is 0.05. Okay? Just tweaking the problem a little bit. Okay, so if you remember how to get your sample standard deviation, we enter the numbers into the list. You go to one variable stats, list one, frequency list, we're leaving blank. We go to calculate, and we want the sample standard deviation, which is 2.512. Okay, it shows us the population standard deviation, sigma, right there, and then the sample standard deviation right there. You want the sample, not the population. Okay, now The only thing left to find is the chi-squared right value and the chi-squared left value. So that's when you're going to have to go to your table. And what we're going to do is our sample size is 15. That means our degrees of freedom is n minus 1 or 14. In the degrees of freedom column, we're going to have to go all the way down to 14. And then we're going to look in that row for our confidence level, 0.95. And then somewhere down the line, there's going to be 0.05, our alpha value. And this is going to be the chi-squared left value. This is going to be the chi-squared right value. Okay? So pause for a moment. Take a look at the table and see if you could pick these values out on your own. Okay? And then once you got your values picked out, resume the video and see what numbers I have here. So if I were to go to the row of 14 and go over to 0.95, the chi-squared left value I get is 6.571. 6.571. And then if I go over to this one, the chi-squared right value, 14 and then 0.05, 23.685. 23.685. Now we have all the relevant information that we need. We actually don't need our confidence level anymore or our alpha. We don't need our degrees of freedom. We need all this information right here to calculate the left point of the interval and the right end point of the interval. So here's the formula one more time. N minus 1 s squared over chi squared right less than sigma squared is less than n minus 1 s squared divided by chi squared left. Alright, so n minus 1, 15 minus 1, that's 14, times s squared, 2.512 squared, divided by the chi-squared right value. Chi-squared right value is right here, 23.685. Notice I am not squaring that number. This is my chi-squared number. I don't have to square it again. I leave it how I found it. Well, that's less than sigma squared, which is less than, well, the numerators match. So 14 times 2.512 squared divided by my chi-squared left value. The left one goes on the right one goes on the left. Okay, 571. And now all you have to do is compute these values right here, punch them in on the calculator, and that would be your confidence interval. So 14 times 2.512 squared divided by 23.685, I get 3.729. And then if I do this one over here, all the numerator divided by 6.571, I get 13.444. Now, let's say you forgot that the chi-squared right value goes on the left and the chi-squared left value goes on the right. Let's say you put this one over here, this one over here, you'll get the right numbers, however they'll be in the wrong spot. You'll have the bigger number over on the left, you'll have the smaller number over on the right, and then that doesn't make sense. A bigger number is less than a smaller number, so that should give you a hint that you mixed up these two, and all you have to do is flip the numbers, and then you've got the right interval. But that's only because the numerators are the same. The only thing that's different is the denominators. That what makes allows you to switch them if you have them in the wrong spot to begin with. Now let's take it one more step further. I think the question only asked us for the Yeah, confidence interval for the population variance. So if I want a confidence interval for the population standard deviation, which is also my next example, all you do is take the square root of both those numbers. So to go from there to there, just square root. Square root of this one is 3.666. There's a fourth 6. Let's see, the other one, square root of the answer, 1.931. So let's go ahead and recap of what these confidence intervals are saying. So I'm going to write the answer. Here's our sigma squared confidence interval. It was from 3.729 to 13.444. And then our standard deviation, 1.931 to 3.666. Now, the problem only asks us to do the variance. We didn't have to find the standard deviation. So, the question asks, construct a 95% confidence interval for the weight of these 15 dogs, okay? Now, we do not know the true population variance of the weight for the adopted dogs. So, what we did, we found a 95% confidence interval for the variance of the adopted dogs, okay? So, we can say we are 95% sure, 95% confident that our interval contains the true population proportion variance of the dogs that are, the weight of the dogs that are adopted. Okay, that's what the confidence interval is saying. Now, we're going to do another example. It asks us to find the standard deviation. The confidence interval for the standard deviation. So like I said, it's very much just finding the variance, and then at the end you're just going to square root it. Just one more step further. It says a random sample of 18 men, so n is equal to 18, so we could find our degrees of freedom. N minus 1, 17. Random sample of 18 men have a mean height of 67.5. And a standard deviation, S is equal to 1.5 inches. Now, I didn't write X bar on there, which would be 67.5, because if we read the question, construct a 99% confidence level, so our confidence interval, so confidence level is 0.99, so that means our alpha is 0.01. Construct a 99% confidence interval for the population standard deviation. Since they asked us for the population standard deviation, the mean height of 67.5 inches is irrelevant information in this problem. If they would have told us to construct a confidence interval for the population mean, then that would be relevant information. We would need the mean height of this sample. We would not need